Swayam Prabha. Digital India. Educated India.
Okay, now let's talk about, fine, we said that if I want to do certain kind of detection, where first primary requirement for me is good visibility of the system, like what is all happening in my system. Okay, so for that maybe I want to keep track of what are the processes happening, process events, about the file events, about socket network events, and even the hardware events, or any possible events that you can log in your system. I should be collect their data. Okay, so now to do this, what mechanisms we have? So anybody heard about log collection mechanisms in Linux? What kind of tools are available to collect system logs in Linux? So anybody had heard of AuditD or Linux log collector? Okay, these are basically, if you see that, if you look into AuditD, it will kind of give you all the activities that are happening in your system. And for Windows, there is something called Sysmon or Event Tracer for Windows, which is called DTW, which also get system level information. But are they good enough? The question is. So as I said, when you want to detect threats in the cyber security, it's not about one event that is going to matter. What matters is the sequence of events, how the events happened. And the correlation between this sequence of events is what matters. So if you want to do good detection of malicious activities, first of all we need to collect the logs properly, and this log should be contextualized. What I mean by contextualization, if you are going to see a process event, you should have the context, like this process is a child process of which process? Okay, is this process is related to the socket, or it is related to the file, or what is this is going to be? You need to have that full contextual information. It's not just enough to say that, okay, I have this process which has this PID, that's not enough. Okay. So that is where, to get a good visibility, we should have a mechanism to collect the logs which gives me full contextualized information. And somehow whatever this I talked about, this Linux AuditD and Sysmon and Event Tracer, they don't give me complete contextualized information of the events that are happening in my system. And because of that, I may miss certain malicious behavior in my network, because my detections are going to be as good as how I can establish the correlations between all the events. And if I happen to miss any of these events, then my detection may be not so good. Okay, then what is a good solution? To make sure that I get all good visibility of my network. So okay, just tell me how you are going to get good visibility of your network. What is your understanding so far of getting a good visibility of your network? I hope you are in track with me. In case not, you can ask me questions on that now. What we mean by getting a good visibility so far, or how you are going to get a good visibility?
By running the AuditD to know the logs of all the, so we can know by running the AuditD in the terminal by running how many processing IDs are running in my network.
But from where it is fetching information?
The processes which are going on.
From the kernel itself?
Yes, sir.
Okay, so you need some kernel hooks, right, to get all this information. So fine, you need to have all the things, everything is happening if I put a kernel hook and probe it properly, I should get all this information, right? What is the equivalent in Windows?
System, event, something.
Okay, whatever. What the thing is, to get good visibility, I need to have monitoring everything happening at the kernel level so that I have visibility of every packet that is going on.
In Windows, we can know by just control shift escape task manager, so we can see all the processes which are.
No, that's not enough, right? That's what I'm saying. It's not about seeing what processes are there, the contextualized information. When it is created, who created it, with what privileges he created it. I mean, is it some process created this as a sub-process?
That fork is.
That's not there. But that information will be somewhere, right? We need to extract that information. So to extract that information, we have some open source tool called OS Query. Anybody heard about OS Query before? Yeah?
So I heard like I didn't work.
In what context you heard it? Okay, whatever. So good, you are knowing it for first time. If you are long-term interest in cyber security, this is one tool you should be knowing. Okay, which is because it is becoming very popular nowadays. And this OS Query was initially developed by Facebook, but now it is open source, and the Linux Foundation maintains this. So this is the one which does the job of getting you all the information by putting kernel hooks. Okay, and the good thing about this is it is very lightweight, and whatever the data it collects, it puts in a database and allow me SQL-like interface to query the information. So for me, now the operating system, it has made it like a database for me. What all the activities that are happening within the operating system is like a database for me. I just need to run queries to get whatever the information I want. And I can even schedule this query so that my information comes periodically to me. And this also has a provision to get the information in a contextualized format, because it continuously logs all the data about every process it has created. You know that in the history of that process. So in a way, like, you have the full contextual information of that process. Okay. So now this has made, and another good thing is I don't need to worry about writing a kernel driver. So another good thing about this, like if I want to get a good visibility, if I have to write my own things, maybe I need to write some kernel drivers and all, but that kernel drivers are very dependent on your kernel versions, and that's maintaining, updating my kernel drivers according to the kernel version is going to be difficult for me. But when I have used this OS Query, that dependency is not there. I mean, OS Query will update itself, and this being an open source, irrespective of what is the underlying kernel version, you will have all these logs being collected. And now how OS Query works? As I said, it puts all the information in a database in the form of tables, and these tables are very structured. Like, you have a table for all the browser plugins, you have a table for all the hardware events, you have a table for all the file hashes, you have a table for all the processes. All the data, that whatever changes happen in your operating systems, they get logged in your tables, and you can query whichever portion you want to. And this has support for all this Linux, Windows, Mac OS, and FreeBSD, and for each one of them, like, they have put it in tables. Like, I mean, those who are interested can look into that. So the basic point here is,
I just wanted to ask if it only does, like, it only logs the system events, and or does it do something more than just logging events? Is it just for events, or is there more to it?
more includes what?
Like does it do anything other than logging just events that are happening? Like,
Everything is like, any changes, you are going to log it.
I'm not able to connect to the
Okay, let me highlight this. Let's focus on the file, right? You write a file. When that file got last changed, that information get updated. So you will have full information like who is the user, who changed it, when he changed it. Whenever the change happen, whatever the changes, the delta change happen, right? That it gets logged in the this tables, OS query tables. So you then in the way like you have history of what all the changes that are happened in my OS. So in that way you have this contextualization. Like if you want to look into some aspect, you know in what context this happened, right? So suppose like some user wrote something into a file. Now you will also get to know through other tables or maybe in the same table whether that user previously had the privilege to write to that, or his privilege was just got escalated few minutes back and then he wrote it. All this information will be there. Okay. And another good thing is this OS query helps you add your own tables. Okay, suppose like OS query don't have tables to monitor your file integrity processes. You can add your tables. Or OS query don't have the options to monitor what kind of DNS query goes on from your machines. Maybe you can add your tables to log that information. So you can expand the tables here. Okay, so that's what I have written here, and you can add all these things. Now once you have this, you are now ready to collect data and train your models. Now why is this? Why is that now we are ready? Because what we did is, first thing, if I want to understand a malware, I need to know its complete behavior, right? Like what process it is creating, what files it is writing, or what network activities is doing. I need to have that at a very granular level. Now I have a visibility tool using this OS query. If I run this and I run a malware, I get all this information clearly, right? Now if I have a malware which I run through my using this OS query agent, I will get to know all the granular activities it is doing. And using the same OS query, like if I am a normal user, I will also get to know all the activities that he is doing. Now because I have record of all the activities are doing, now it becomes easier for me to differentiate between the two. It is basically I am getting a much richer information using this tool, all the activities or the behavioral aspects of a user, or it's like a malicious user, whatever. So first what we can do once we have this setup, first if you want to, before you want to train some algorithm, you need to generate the rich data sets. What we can do is, we can create a sandbox. Let's say you can make a virtual box, virtual machine. Let's say you have a malware, you put it in this, you also put your OS query agent in that and let the malware run. Your OS query agent will log all the details, all the activities that malware is doing, right, at a very granular level. Now you collect this information, like you build your data set. Now once you have this data set, these data are usually humongous because it has collected everything that your application is doing. They are going to be very, and this will be like what? This is not like some numbers. This could be like, okay, this created this PID, and this wrote this file, this application accessed this file, it has this read and write permission. So it will be like lot of non-numerical information will be there in your log file. So now that's not enough for me to train my algorithms, right? What you are going to do then next? You have to process it. But now how you are going to process? Like you have a file path, how you are going to change it to number? You have a PID, how you are going to change it to a number?
So we can define our own set of things like for them.
Right.
By using OS query, we are logging the whole behavior, sort of, you can say, of the malware, how it is behaving in our sandbox, right? But who is giving us labels?
I know it's a malware.
In the label.
I know it's a malware.
No. So in the sandbox, there will be a malware, and there will be another processes also running, right?
So that's what, when you create a sandbox, right, you have absolute control over your environment. At that time, you are only activating you are only running that malware.
So it is just collecting the sort of, you can say, feature vector of malware.
Yes, at that point.
So how are you going to scale it to, or you going to generalize it to other applications?
See, whatever the malwares you want to detect, right? It could be anything, like any malwares. Let's say it could be a combination of ransomware or other kind of malwares. You run in your sandbox. In your sandbox, you are just like running your own piece of malicious code. You have these logs, and you know that these logs corresponds to the malicious behavior. That's it.
But it will not generalize, it will only learn the in distribution, changing distribution, right? How will it generalize the learning of the algorithm?
So learning, I'm still coming. Like right now, we are only talking about generating the logs of this malicious.
Okay. In the context of generating
Yeah.
the log,
Yeah.
we have temporal information also, right?
Yes.
In OS query.
Yes.
So on the pinpoint of contextual information and chaining, the chaining perspective.
That chaining algorithm will do.
So if you want to prove chaining of a malware, the behavior of malware, so you must incorporate the temporal information.
It will be there. Temporal information is there in my logs. How I am encoding that and chaining them, it's my algorithm, how I train, what architecture use. Yes, that's the part of my algorithm architecture and how I'm going to come up with the algorithm.
At this point, we have log files which contain a huge feature value mapping of only malware.
Malwares, yes. And similarly, I can also get this for the benign activities also like this.
So but the thing is that if you do the benign activities and malware activities at the same point,
We are not doing that.
in the same sandbox,
Yeah.
then you will generate a lot of feature value mapping, and there will be a class imbalance problem in that.
See, agree. That is what the whole point of creating a sandbox is. You have absolute control over what is going to be run there. I'm not running it on my regular machines. Okay, this is totally isolated environment.
You just want to learn the distribution of malware activity.
Malware behavior, like its log files. Now, once we have them, I'm not getting into that. Like you can repeat and collect these logs for different set of malwares. Generate your log files for that. That is basically capturing their behavior, all the aspects, temporal aspects, and whatever that granular information output, their process file, socket activities, everything. Now, there are two ways. The class imbalance problem is always going to be there. It's not that, especially if I were trying to train for Linux, it's not that you are going to get a tons of malwares in the market. Like maybe you will see very few malwares for the Linux. Now, how you are going to do that? So that is where we need to tell our algorithm what is a normal behavior and what is not normal behavior. What we need to do is, we have a lot of logs from our normal behavior, right? Normal behavior we can generate as many we want to say, and maybe from the abnormal we will have few. Now we can train it and say that whether it's a normal behavior or not. Even though there is a huge class imbalance here, but we have trained on the normal, my system understands what's normal behavior well. But anything slightly different, that maybe it will tell it as abnormal. Okay, but we have also told it what is abnormal because giving some samples of abnormality, right? That is what we have collected a lot of granular information here.
So this type of architecture will not work in real life setting. I have tried this.
I don't know, that is what, this is all proprietary. I am also not claiming it is work. These are just ideas because anybody who has claimed this work, nothing is in public knowledge.
So
This is a standard thing to learn.
This is like, yeah, this is how you make. If you are not made it work, I absolutely not at all denying it, this did not work. For those who work, nobody has made it available how it works.
no, I have seen a lot of projects such as artificial systems do work, and the thing which this architecture supports is it's just we are learning a distribution of normal packets, and then we have some information about abnormal packets, and then we are just somehow we are calculating that if it is normal or
Now somehow will not work. That is where you need to be precise. I mean, everything lies in making those somehow precise, fine-tuning lot of things. So if you look into any tools that are in the Marwade, right, everybody has, and I don't know how things that work.
we are just telling that the distribution if anomalous particle is different from the distribution, right? Using what we are teaching about here.
See, again, it is not just like as plain as that. I'm not saying that this is couple of things here. I mean, you need to do this, but this will be not the only component in your final detections. As I said, there will be a lot of open source intelligence you have to use in combination with this. These are also going to give you certain scores. Okay, this could be potentially malicious. And you need to use combination of other aspects to make a final conclusion. If you're just going to use this, I'm telling you will be flooded with false alarms. So this is just going to be one step in multiple steps you're going to use to make a final conclusion. So first of all, you will get some scores. You are, let's say, you have given certain techniques or observed, you are going to put certain scores to them. And then you need to combine that scores across multiple techniques to make a claim about it is malicious or not, and how you are going to assign a scores, that is very subjective, and that itself use lot of open source intelligence. Okay, this is something as you saw, right, like, yeah. Encoding part, yes, because we ourselves don't have the complete encoding point, how to do that encoding. Like, we have some very heuristic way of encoding them. That is all very, I would say that hand encoded, just looking some experience. Okay, if this file is read, maybe we'll replace that file by some score. How that score it is, like if I tell you this is the scoring way I used, I can't explain you this is exactly the reason, like there goes lot of heuristic there. And that playing about that encoding is what is going to significantly affect your performance. Okay, now quickly, I want to just show one implementation of all this, like OS query running on agents, how we are going to collect all them at a central locations, how we apply all these rule sets there, and how these alerts are getting triggered. Okay, let me show this. So when the whole system works like this, these are your endpoints. Let's say you want to monitor, these are in your network. You are going to run your agent there. It is like an agent, OS query based agent. You are going to get the logs of all of them, maybe bring it to some central server. Those logs will be humongous. You can't directly search over it. You need to properly index them and put it in a database. And once they are in a database, you need to process them. You need to create the process tree, like which process created, which child process, and that entire tree you have to build. And once you have that, now you are ready to apply your rules. The rules are now going to be based on the TTPs that I discussed as per this Maitri attack framework. if a certain technique of a tactic is observed, that get triggered, and we are going to display certain event has been triggered. But itself does not mean that there is a malicious, but it's just a trigger of a certain tactic being executed. Okay, I will just not go into that. Okay, what I will do now is, let me quickly show you that interface. Okay, so this is the tool we call as Vajra. So now you see that as I said in our Vajra, right, there will be certain nodes or the endpoints that we will be monitoring. So currently we are monitoring about 10 machines. Out of this 4 are active now. So 4 are means they are online. We are installed our agent on 10 machines, but 4 are of them are online and they are sending all the logs to my system. Others are offline. Now if you look into this alert page, this is where I get an alert. When certain activity happens and this is associated with certain technique of a Maitre attack framework, we will that alert get generated. Okay. And now here is what the process tree looks like. This event, this alert is got triggered due to this event, but before this event is happening because of this sequence of actions, this sequence of activities. Okay, here you see that process tree, like here this is the PID that generated the alert, but this PID was previous, his parent PID is this, and we can trace back and go to the root PID. And this is what is going to matter, right? It's not that this PID has been created, but which is the sequence of PIDs that led to this PID is what is going to decide whether that was a malicious activity or not. And this is what we want to encode properly, appropriately in our logs so that my algorithm can better understand what is malicious or not. Okay. So now quickly I want to show you. Yeah, so this is going to show us like what are the alerts triggered, and they are coming from which machines. Like we have some machines with Fedora, Kali and Ubuntu that is being shown here, and it also shows that these alerts corresponds to which of this Maitre framework, like how many came due to privilege escalation, how many came through due to persistence, how many came through defense evasion and all. But as I said, these alerts being generated here, it does not itself mean that this is a malicious behavior. What we need to see is on this we have to build another layer which is going to see the sequence of alerts and then chain them to see it is a malicious or not. So I hope you understand this basic premise. So these are all just certain techniques has been observed. But if you are going to see different techniques, maybe when you connect them, chain them, maybe then you will see that whether that is corresponding to a malicious attack or not. Okay, so with that, so when you have such a tool, right, you can do lot of you can get all the logs of your system. You can do detections, and then you can do investigation if certain event has happened, why that happened, as I said, because you have all the logs in a very contextualized format. Okay, so that's it. Like with such a system, you can do real-time monitoring of your threats. And by the way, I forgot to tell that here we have something called threat hunting. You can do live queries to your system to gather any additional information. For example, if you want to see at that point who are the users who are logged into your in a particular node, you can just send a query here and see that a particular user executed this command. You can just ask here, do a live query to see that user executed that command. And based on that, we can do like how the threat is originating and propagating in your network. Okay, fine. So that's what we are saying. We can do this real-time threat hunting here. And also, by the way, how many of you heard about this BOSS system? BOSS, anybody heard about BOSS? What is BOSS? Huh? Yeah. Nobody has heard about it. Okay, this is like a BOSS is Bharat operating system, right? Yeah, this is like all our governments run on this Linux variant, not like standard Ubuntu or Fedora. Yeah, you can download. And people will really appreciate if you can contribute here in improving. It is like, I think, open sourced.
But it doesn't come in GSOC, so nobody
It does not?
come in GSOC like online.
What is GSOC?
Google server code or
Oh, I see. I don't know why. Yeah, but still, if someone is interested, you people should contribute here. And also, like, we can get to see what is, like, if there are some containers running in your machine and some applications are running within this container, we can also see what is the activities that this application is doing within the container. Okay, that kind of visibility can be achieved. So yeah, and then once we have these alerts, we can do this AML models, and you can train your models. You have a lot of data now, rich granular data with lots of visibility. It's up to you how you want to train and tune it as per your requirement. Okay, that's all. With that, I will conclude this. If you have any questions, we can discuss now. Okay then, thank you everyone. Bye.